Is the screen visible now? So this is the working copy of our software. Just a minute. So here, as you can see, these are the icons from which you can access. This icon is for opening your offline library. Here, you can see my offline library is here. From here, you can select any robot, any gripper, any part or any object. Here is the icon for, just a minute, there is some delay, I think so.
Just one.
Now I think it might be okay. Yes. So this is the online library for our RoboDK. From here, which they have provided many more than 500 to 600 robots. Here you can see 6-axis robot. Here is the delta overhead robot. Here is the 6-axis robot, delta overhead robot. Here you can select it from the various types of brands from the drop-down list, such as ABB, Fano. Here you can filter the details you need. Here type 5 degree of freedom, 6 degree of freedom, 7 degree of freedom. Here you can select the axis you needed. Here is the reach. Here is the payload capacity.
શાંતિથી કરજો.
Hello.
કાલ મારે ઉતાવળ નથી. સ્કેન કેમ સ્કેનર થી
Hello.
સ્કેન કર. એવું તેવું નહીં, ફોટા જેમ તેમ પાડ્યા ને એમ નહીં. હો ને? કઈ સાઈન અંદર બાકી નથી ને?
Hello.
પાછળ જ આપી સાઈન આપો. આજે નો યાદ આવે.
Can you please okay.
Yes, thank you, sir. So here you can filter your like what you need. Here you can filter the payload capacity, weight of the robo, repeatability of the robo, and you can select any robo from here. So this is our online library. This icon is for adding a reference frame to your working space. From plus, the sign of plus and the minus. You can shift the reference frame. You can shift the size of the reference frame here. So this icon is to set the targets. Here, this most of the icons will be explained as going further. So here, if I take a robo, so for example, I took a 6-axis ABB robo. So if I double click on this robo, you can see here teach pendant of the robo. This is the teach pendant of the robo. Here like this. This. You can move it. You can move it from the joint axis also like this. Here it is the teach pendant. As you need to move it, you can move it. Here from each joint it moves. Here are the options to move. See here you can see the reference frame moving at the front joint. Like this. Here you can select the axis. Hello, can you see my screen clearly? Can anybody reply, please? Hello. Anyone?
Yes, sir. Yes, sir. You can see.
You can see the screen clearly. Is there any delay?
There is slight delay, sir. There is slight delay. Otherwise, it's okay.
Okay. Okay, sir. Thank you. So here you can move from your joint movement. Here you can move according to the axis. If you select the y-axis, it moves according to the axis. If you select x-axis, it will move according to x-axis. Here, if you select z-axis, it moves according to z-axis, like this. So this is the teach pendant of the robo. Once I say home, the robo goes to its home position. Here you can see the parameters. Here you can see there are parameters options. Here are the robot parameters. So these parameters are only available in the licensed version. If you take the free version, you can't access to the parameters in which you can see the inverse kinematics. Here, this is the table for the inverse kinematics of the robo. Here are the kinematics parameters. Here is the speed, acceleration, calibrated model, joint speed, joint acceleration. You can see everything in the robot parameters and you can change, like just change according to yourself as you needed and try and test it. So this is available only in the licensed copy of this. You can't access this in the free version of the robot demo version. So now you see the parameters of this. Now I will show you the concept of reference frames. So these are the reference frames. So now if I select a gripper, now I will show you from the online library. Here I search gripper. If I say enter, see here are many types of grippers. You can choose any one as per your use. So now I will take a two-finger open gripper. Here robotic two-finger open gripper. If I say open and close, see it gets attached directly here. So how it is attached to the robot directly? It is because of the reference frame. You can see here. This is the reference frame of the robot. Here this one, and this is the reference frame of the gripper. So if the reference frame of the gripper must be at some other side. So it won't be attached directly to the robot. It may go some slightly at the right side or left side according to its reference frame. So reference frames are most important thing while programming in RoboDK software. So now I will show you one example. So I will delete this gripper. I will attach a pencil gripper here. This also is attached directly to the robot just because of the reference frames. So now I will show you setting targets in this. So I will mount this robot firstly on the table. Here table is there. So it gets mounted directly on the table. So you can move the robot like I said you prior from here also like this. Or you can, there is a simpler way. You can select this option and you can move it by selecting the reference frame. So now if you select here in another axis here, you can move the robot. Just a minute. Here. If you can see here, you can move the robot accordingly while selecting the reference frames like this, like this. You can just move it like this. Now, if you can't see clearly, I will minimize the reference frames. So here I will select a target. This is the option for setting a target. Here I set the target. You can see here. I will go here again. Just a minute. Here we'll start from the scratch. I'll take the robo. I'll take it here. I will attach a pencil gripper to it. As you can see here, I'll set the target here, move it on this side, set another target, move it downside, set target here. You just need to check the movement of the robo and set for target. See now, if I single click on the target, the Robot moves according to the set targets. So now to create a program according to these targets, you need to select all the targets. Target 1 to target 4. Right click on the selected targets and say create a program. It creates a program here. See if you can see like this. If you double click on the program, now you can see here. Actually, if you can see here in this tree, movement J target 1 is a joint movement. This is because of the singularity. If I right click on this and say linear movement, it will move straight like this. And you can just right click on the program and say run in loop. And you double click, the program will run according to itself in a loop. So, one project, like to say, this is a very basic project to like make a rectangle setting targets just to tell you. Now I will show you the further programs for like pick and place, attach and detach objects, like setting targets, picking the objects. I'll delete this, just a minute. We'll start again the another program. See now you can see here I have attached a gripper, which is an open gripper of robotic company. I will double click on the robot. Like this gripper is vertical. If I need it horizontal, I will just move it from here. See here it's moving. Now as the I will take it to 90, means it will proper horizontal. It's like this. I will see here. Now if you need to take a cube for picking and placing. So I will take a cube. I will show the experiment with the cube of 100 mm. Here, if you double click on the cube, you can see the parameters of the cube also. If we change the parameters here, it will change according to its axis. Now this is moving into x axis, into y, and if you see here, it also moves into z axis also. See here. If you can see. Now I will take this cube, move it according to its axis. Now if you can see here, the reference frame of this cube, it's at its corner. So when I say the robot, you can directly give the order to the robot to pick the object up. Now when I give this like this, see now here when I right click on the object, say get with the robo and select the robo. See here, you can see here, just I told you prior, the all game is of the reference frame. So it has selected the reference frame, corner reference frame of this cube, and to make this make this resolve this issue, you need to bring this reference frame to the center of the cube. So double click on the cube. If you see here more options, move geometry, the only cube will move according to its axis, but the reference frame will be at its same position. So as the cube is of 100 mm, we will take it in 50 50 50 here like this, 50 50 and 50 here like this. And so now when I say get with the robo here, if anyone have any problem, please ask if there is any issue while in middle, so I can understand if there is any issue. See now here when I say get with the robo, see if you can see here, it goes directly. Now here also you can see the gripper is going through the object. So See here, like this. So this is because the reference frame is in the center and the reference frame of this cube. If I take it to 90 here, 90, and now I say get with the robo. See here, perfectly you can see both the reference frames here, it's matching the red and the green. Like this. Now you can see here it don't go through the object. So when I take it here, I give the command. Now here see I set the target to this robo. I will take it a bit upside. Set one target here. Right click on the object, get with the robo, set another target. And now if we select this both programs and say create a program, see it creates a program for going upside and down, getting with the object. So here you can also create a program from this. This is the icon for creating a program. So you need to create a program. Now this program is not defined. Click the program, select the target one, click the program and say here joint movement like here this. Now select the program, click target to say linear movement. So if you click the program, see here, you can see the robot moving according to it. So now we need to attach, say the simulation event, we need to attach a simulation event to this target second. So here you can select this program. See, this is the icon for adding a event. So I will click this, select from the drop down list, attach object to the gripper. Now here, as we have only one gripper, it is showing only one gripper in many further projects. If we have two grippers, three grippers, you need to select the gripper from the drop down list. As we have only one gripper here, so it is only one gripper is there. So if we say OK, the object is attached to the gripper. Target program, and we need to bring it back to target one, select target one and say linear movement. So once I double click on the program, simulation event is activated here. Here it will attach like this. So this is the basic for attach. Now I will show you to detach. So I will take this position, move this object to a desired position. See here, move it to its desired position we need. Like this. And we need to like say detach object. So again, we will select other targets. Now here we will set another target, target 3. And here we will set target 4. So now it will, now this gripper is object is attached to the gripper. So now we need to detach it to the target 4. So again we will create another program here. We will create a program. This is undefined. We will select target 3. We will say joint movement. Select the program, select target 4. We will say linear movement. And here we need to set an simulation event for detach object. We will again go to the event instruction. In the drop down list, select detach object. Here you can see here we need only one gripper I said you. And to where to detach this object, you can select it from the drop down list. Now we need to set detach the object on the station 1 like on the table. So we'll select new station 1 and say OK. Again, select the program, say target 3. We need to leave this object on the table and move the robot to its desired position, like target 3. So select target 3 and say linear movement. So once I double click on the program 2, it will detach the objects here. Detach the object. So this is the basic program for attach the object and detach the object. So I will show you one my ready-made. I have made a ready-made station from here. Just a minute. Stations. Here, pick and place. So as you can see here, sir, is the screen visible? Hello. Hello. Am I audible? Please reply somebody.
Yes, sir. Yes, sir.
Yes, yes. Thank you. So here as I made a program for attach and detach, see if I run the program, you can see here, it takes the object and leaves here. Here. It takes the object and leaves here. So now I have added a new program also here, program 3 of replace object. So once the object is attached, detached, the object automatically runs the program 3, which is for replacing objects here. As you can see, this is the pick and place with replace objects. Now I will show you pick and place with mechanism gripper. You can also do this with mechanism gripper. First, I will show you the mechanism of a gripper, how you can do it. So see now. Now I will just take a gripper here. See. Now this is the gripper as you can see. If I double click on this, this is the axis job movement. If you can see here, close and open, close and open. So now you need to firstly create the program for the gripper. Now if I select this, set a target here and name this target as open. Here, open, enter. If I close this gripper, set a target here and name this as close, enter. Now you can see here the target for open, target for close, like this. Click on this. To your ease of the experiments, you need to create a program for this also. So if you right click on this and you say create a program, so you need to make these targets as a joint move. See here, if you can see, open and close is going. See, open the gripper, close the gripper, open, close. So whenever you need to, like whenever in the program you need to add a like open movement or close movement, you just need to add a program to that time. You don't need to like every time select the open and close or gripper. So I will show you pick and place with open and close gripper. Here, if you can see, this is open and close gripper. See, it closes, fix the object, it goes to its desired position, and again opens the gripper. Now I have set here the replace object also. If I run it on loop, you can see here it closes, it moves to its desired position, and again you can see the movement of the gripper. It opens, it moves towards home. As the program is on loop, it will run again, close the gripper, go to its desired position and open here if you can see the movement. So let's move to our next example. So next example, I will show you of pick and place. We have done it. Now I have also done it for curve follow. Here you can also have a function for curve follow. So if in any like uh, if there is any program for following a curve or usually in weldings, you need to follow a particular path. So for selecting that path, here is the option of curve following. So I will attach a dispenser tool for this. I have attached a dispenser tool. I will place this robo on the table. Like this. I will take a basic to just show you the open like curve follow project. I will take it beneath the robo. By moving By selecting this reference frame, you can simply move the robo. Now, once you take this above the object, you need to go to the utilities section. Here is a curve follow project. They have given you the direct option to select the curve. See here, you can select the path settings. You just need to select curve, say here select curve, and you need to select which curve, on which curve you need to run this program. If you can see, these vectors are very much important. Here, if you select this curve, and if you say done, here you say update and say simulate. Here, if you can see here, just a minute, let me minimize this, close this. See here, if you see, you can also select this icon is for setting the simulation speed. See, if you move it slow, it will move fast. If you say it's slow, this is the program for curve follow project. Now, on the same basis, you have a program for point follow. With the same tool, we will be seeing point follow project. I need to delete the curve firstly. I will take this robo again upside. I will show you on this same. See, if I say here in tools, select the curve, create the curve. For this point follow project, you need to create the curve, select the curve, and just say done. Right click on the curve, say split curve, and split curve in half. I will show you I will set point spacing of like 30. Okay. See, the curve is splitted with the point space of 30 mm. So now if I say right click on this and say extract curve points, go to utilities, and here is object for point follow. So I just need to select points here. Once I extract the curves here, one, I'll select the points here. Okay. I'll say done, and see here you can see update and say simulate. If you can see here, it moves to the desired point. Now this program you can see mostly in spot welding. Spot welding, we need to weld the spots, particular spots we needed. So I've showed you the basic for curve follow and point follow project. This is how to create the curves and create the points. Now I will show you the ready-made. I have made the ready-made stations for curve and point both. So this is the station for curve follow project. If you can see here, it moves according to. I'll just increase the speed little bit. If you can see, I have selected the all the curves of this object. It moves according to the desired path. You can see it considers its movements according to the path. If you can see here, it follows the curve as I have selected. This is the project for curve follow project, and here I will show you for point follow. Point follow. Now here, as I showed you prior how to select the points, I showed you to select it on only one side of one curve of the object. Here I have selected on the both sides of this object. As you can see here, the robot is moving to the selected points. Now it will automatically move to the another curve of this object. If you can see, I will show you from this angle. Here it moves on the both the sides of the object. Now these are some of the simple projects you can do here. You can do most of the projects, and now I will show you the assembly. You can also do assembly here. I have made a object like assembly project, basic assembly project. If you can see here, this is based on the pick and place on attach and detach object. As I showed you prior, you can select it from here. Wait a minute. See, if I say pick the object, the robot goes, picks the object up. If I say place the object, the robot goes and place the object on another object. Now this object is just placed. And if I say assembly, the object moves here. See, you can see, as you can see, both the object move as these both are attached to each other. So here in this simulation event, see here, it is attached. We see. If I say replace objects, both the objects will go to its desired position. In this simulation event, if I say detach object, you can see here. Here I detach the object on cube 1. This is the parent to my another object. So because of that, it is assembled to each other. So on this principle only, there is one more project I have with Scala Robo. Here you can see the Scala. This is the Scala Robo. Here you can see this is the assembly project on this Scala Robo. You can see here, if I run the main program, it goes here. See here, I have done this with open close grip only. It selects the visors. If you can see here, it places the visors. Takes another part and it assembles here. You can see it is picking up the whole assembly and placing it here. I'll just move the simulation speed. See if you can see here. This is the project for assembly. It picks up one object, it places the visor on the object, and it picks up another object, and the assembly is ready. You can see here. So this is the project for assembly. So here in this software, they have, as Praveen sir told you prior, in this online library, they have provided you ready-made stations. If you can see here, this is the station library. If you can see, there are more than 70, 80, nearly 100 stations, ready-made stations available here. See if you can see here. Now I will show you just basic one or two stations here. See if you can see. This is the basic station for curve follow. You can just open, say here open. These are the stations for curve follow. These are the stations for curve follow using dispenser tool. If you can see here, various robots, various parts are available here. You can select it. You can also search here from this library. Anything if you search here, like drilling, the drilling station will be open here. See now this is the station for curve follow. This is the ready-made station. If I say run, the program runs to its desired path. Now here, if you search drilling, here how many stations? 4 stations are there for drilling. You can open any one and see here. See if you can see. And if drill the part, simulation speed is a bit high. See here. You can see drilling. This project is based on only point follow project. You need to select these points, attach a tool of drill. Here if you can see. These are the ready-made stations available in the library of RoboDK online library. So now we will move further. Praveen sir will show you the custom making of custom grippers and making of custom robots.
Sir, I have one
So-
doubt, sir. Sir, I
Yes,
have
yes,
one doubt.
please, sir.
Sir,
Yes, please, sir.
actually, we are creating all the modeling, everything, cell, everything in RoboDK.
Okay.
But
Yes.
I want to generate a program out of that modeling. That means, for example, we have programming language, no, like we want to move to this, like this, all those commands. How to
Yes,
generate
yes, yes,
the modeling? Can you show that?
Just a minute, sir.
Or if you
Sir,
write
if you
a
can
program,
see, no, sir, you can't write a program. The program are already set. Python programs are there. The RoboDK supports for Python.
at least the student will be doing the modeling, everything. But later, I want to download the program so that
Yes.
I can see how that works. How can
Just a
I
minute,
do,
sir.
please?
You can see here if you can. Just a minute. Now, if you can see here in this pick and place mechanism program, see this gripper has a program for Python program is there in this gripper. If you can see, this is the Python program, sir. Already the program is already set by the makers of the software. You can't change it.
10:30
But
valdu
it,
9:30
it supports to Python, sir.
సార్ మీటింగ్ లో ఉన్నారు సార్ మీరు ఆయన అదే ఈ సెట్ కానీ ఉన్నారు సార్ ఇప్పుడు మీటింగ్ లో ఉన్నారు సార్ అని వానికి అంటే నాకు తెలియదు ఈ సెట్ కానీ ఉన్నారని చెప్పిన కదా సార్ బిజీ ఉంటారని చెప్పిన
Hello.
ఆయన మళ్ళీ ఆయన నీతో మాట్లాడే కదా మీటింగ్ లో ఉన్నా అంటే తర్వాత మాట్లాడు
Hello, sir. So now we will further continue with the custom making of custom grippers and custom robots.
Yes, sir. Sorry to
Yes.
interrupt. Can you show it once
Yes, sir.
again? I have some net
Okay,
problem. I
sir.
could not see.
Sir,
How to generate?
actually, see if you can see here in the software, this supports for Python program. Here you can see add Python program. So here,
Okay.
here it is. I can't show you right now because some time limits are there. But if you can say,
In the library, for example, you have created
Yes,
a
yes, yes.
robot for pick and
Yes,
place or welding. For that, can you
Yes.
generate the program from that model?
Sir, the programs are already generated by the it are internally applied to the station, sir. If you can see here.
Can you add his own? His question is, can you do your own Python? Yes.
Yes, you can do it your own, sir. Your question is that if you can add your own Python program to the if you need to add your own program in this project. Is this your question?
No, it's not like that, sir. I have modeled and created a pick and place robot, but I
Yes.
want to see the basic behind the screen. What is the program happened? I want to see that. How to see that program? That's my question.
Okay, how to see the program? Like they have set a program, so you need to see that program. That what program is set by them for pick and place.
We have model pick and place or painting, welding, anything. That robot movement is happening. But
Okay.
behind the screen, there is some program. No, sir. How to download that program that I want to see? What download that Python program? In fact, we are not doing any program. We are modeling everything and running it. But I want to see what is behind the Python program that is generated. How to see that?
Hello. Yeah, can you hear me, sir? This is Praveen Bell.
Yeah, please.
Please
Please,
give me
sir.
the screen. Shut down your- Shut down your speaker
Yes,
also.
sir.
Hello.
Hello, sir.
Yeah, see, there was a question about the program, correct? Now, see now, RoboDK has few things available. One is it's got an entire RoboDK API. Before the API, there's one section that RoboDK has got post processors, an entire list of post processors. So if you want to create a program which you want to later on go and tweak and fine tune before sending it to a controller, etc., you can generate a post processing yeah, that is one option. Okay. Second thing is for we can't show it to you right now. We'll send you the details and we'll conduct a separate session. But we have Python, we have C# API. We also have a MATLAB API for people wanting to do in-loop control for this thing. Another thing is, if you see here, RoboDK has support for C#, Python, C++. Okay, this is available here. Again, here if you see Visual Basic .NET is also there, MATLAB is also there. There's the entire section for the programming part of it. Now, only thing is how to access that program, how to tweak it, fine tweak. We'll get back to you on that. But yes, it supports either as a post-process file where you have the entire program available on your hard disk, or inline programming also. Yes, we have this support here.
Sir, can you show that you created some work cell, no, that pick and place all those things. You created the model, it is running. Now after that, the student want to download the program. What is that program behind Python? How can I download it?
Can we send it to you later on, sir?
Okay, right.
Okay, we'll do it. Don't worry, it is there. I know 100%. We'll do two things. We'll show you the Python script generated also, as well as the post process file. Both. We'll take 10-15 minutes of you later on. Okay. Okay. Now we'll get back to you on that, sir. Definitely. Now in RoboDK, there are these model mechanisms section here. Okay. Now there are quite a few requests in which people said, 1 minute, just see in the meantime, you can check that Python program and you can finish it today only. So you can create different types of mechanisms here. 2-finger gripper, 3 linear axis, Cara robots, etc. These can be created. Now, what I've done here is I've taken CAD files. Okay. So let's say I take a gripper base. This is a gripper base. I take 1 minute. I take 1 finger and I take a second finger. Now these can directly be imported and pasted into the environment. This can be a CAD file from either STL, IGS flat file format. These can be taken. Okay. Now another thing is you can also, for better understanding, you could just maybe change the color. Let's say I want to change this object color. Okay, I've done this. So this is what my imported CAD model is. Now, after this, if I want to create the mechanism for this, I go to model mechanism of robo. I go to 2-finger gripper. Now, in this section, if you see, there is a particular reference frame and those axes along which these fingers are going to move. And here, if you see, if I align this part in that particular reference frame, yeah. So in this mechanism manager, if you see, the gripper fingers are going to move around the red axis. Whereas in this model, you see the fingers are actually in the opposite direction. And if I try to create a mechanism here like this, let's say update, what is going to happen is it is going to move like this. So this chart here, which tells you exactly how to model this mechanism, is very important. It is just to point out this particular thing. Now, to solve this problem, you can come here. Okay, and you can rotate these objects. Yeah. We move this by 90 degrees here. We've done this here. Now this is where we've got the right alignment. Now I'll go back and I'll say create the mechanism for the robo, 2-finger gripper, take the base, take joint 1, take joint 2, I say update. And now if you see this, I've got this in the right direction here. Now I need to set the limits of this gripper. So let's say this is here. This is around, let's say this, make it 0. This is 0 and this is around, let's say 20. Yeah. So in this fashion, you can define this particular movement in the right directions. Then if you go to the parameters, we also have these other options available here. This is for the sort of the inverse kinematic settings for this particular gripper. Speed, joint speed, acceleration, all these can be set for this particular gripper. And here you see either there are two solving methods. One is iterative kinematics and one is the regular kinematics. Both options are available here. Now, after this is done, I can right click and I can say save this as. I say save, and let's say I go and save it in the library as G02. Okay, I save this gripper. Then I come to RoboDK library. I take in a ABB robo, for example, here, and then I go to G02. So this is a custom-made gripper which I had created. Now this will also behave the way it is supposed to behave. All the commands will apply to this, what Kunal had shown previously, open, close, etc. These are available. And this will now move with the robo also. So this was a custom gripper. Now coming to a more complex mechanism, let's say a 6-axis robo. So let's say RoboDK custom robo. I have these parts here. These I've downloaded from the net, from one of these free CAD objects which I get. And I've taken a base here. Okay. This is a 6-axis robotic base. And for a 6-axis robo, if I go to the mechanism part of it, yeah, you can see that the reference frame directions are in this particular fashion. This part is totally misaligned. Okay, you can see here this base white part here. And for that reason, I have to now move this particular in the correct direction. Yeah. I turn this by 90 degrees. So if you see here, I've got this in the right direction as required by the definition for this 6-axis robo. So this part is now done. After that, now I want to put in the second part here. So I take a second part here, that is the second, this one here, which is attached to the base, between base and D1, theta 2 here. Okay. Now this particular part again is misaligned. So what I do is I align this also. This part, it is still in the wrong rotation direction. Okay. Okay. So now these two parts are aligned properly. Now after this, let's say I create a joint between base and link 1. and I say update. Okay. I say update. I've got the mechanism between the basic two parts here. So this part is now correctly aligned here. Okay. So in this fashion, I can keep putting in my parts in this particular file here. So I can, 1 minute, where is the screen gone? Okay. Now let's say I put link to. Now link to also is not rightly aligned. So you go here, I can shift this part. Okay, again I have to rotate this. So I rotate it, I put it in the correct direction. And if you see here, this is where the definition is given. If you see these parameters here, D1, theta1, A2, if I match these properly here, I can actually get the entire robo to get it properly aligned. And I have already kept one ready. Okay. RoboDK custom robo. So if you see here, this robo here in the color, different colors, this is what has been made as a custom robo. And all these parameters here can be applied to this particular custom robo here. So this definition, in fact, there is a method I've not done it previously. You can actually copy paste the inverse kinematics of another robo and directly paste it into these tables here. I've not done it, but yes, it is possible. Yeah, here it is. Copy and paste here. So this robo can be saved and it can be ready for use. And even this gripper here is now attached. This is a ready-made gripper attached to a custom robo here. The main criteria is that in the mechanism section, you have to follow these tables properly here. For an industrial robo, it is this. Then for a collaborative robo, it is slightly different. You can see this definition of the robo here. Yeah, this is slightly different here. So you can choose what type of a robo you want to create from scratch here. And then changing these D1, D2, A2, you can actually realign an entire CAD geometry to make it behave like a 6-axis collaborative robo here. So this is possible. Any questions, sir? Sure. But I don't have that model on my machine. I'll stop sharing. Where? Which is this thing?
Online station open and place. Open close gripper mechanism.
Where?
Station.
Hmm.
Open close mechanism. नीचे वाला.
O से है क्या? Does it start with O?
Pick and place रहेगा pick and place.
Which one? No. What is the model number?
Mecha gripper example. Mecha.
You just want a gripper, right?
वो स्टेशन रहेगा तो भी चलेगा.
Which one? Yeah, Mecha. This one.
No, not that one.
Then
Down नीचे रहेगा. This one.
open.
Open. पास सेट किया है कि नहीं मालूम नहीं।
You just show it now. Stop sharing from here. Stop sharing.
Hello.
Yeah, he's just showing you where.
Hello. Hello. Am I audible?
Show the thing.
Shivarama sir. Hello. See, as the question was there prior before showing this custom gripper and that if you can see the Python program. So this is the like project for pick and place. So you can see here, this is the Python program on this this project has got a Python program for pick and place. If you right click on the Python program and see edit Python script, the window opens here and you can see the actual Python script here. This is the Python program. If you can see here, and you can edit it from here also. You can copy this program, you can select it like this. So you can do it for any other project also. You can see edit the Python script. It opens the window for editing. Here, if you can see, this is the Python program for the particular pick and place object. Okay.
One.
So any questions till now? Hello? Hello? Am I audible? Hello? Hello, if there are any questions, please tell us because now we are at the end of the session. So the feedback form is sent to you on the community. So please fill the feedback form from there. And if you have any questions, please ask now, or you can send a message also in the community.
So can you show that just now I asked, that program?
Yes, sir. Yes, sir. I showed you just now only, but you were not available. Just a minute, I will show you. I was showing you right now.
Show that.
Yeah.
The one is Python. Second thing is right click on program. And my mic is closed. Just show some. Show the Python or the ready-made one.
Sir, you can see my screen.
Yeah.
Yes, sir. So if you can see here, this is the project for pick and place.
Yeah.
And here it is the Python script, this one. If you right click on this and you see edit Python script. If you press here, see here, window pops up and this is the Python program.
This we can download.
Yes, you can copy paste here, sir.
Okay, okay.
You can edit it here also if you want to edit it and like allow it to change it in this program, in this project.
So we can also edit.
Yes, you can also edit it. Any other questions, sir?
No, thank you.
Okay, sir. Thank you.
I need to talk with you regarding this RoboDK software.
Yes, sir. No problem, sir. I'll tell my colleague to call you again.
Yeah.
So if you have any doubt, you can please ask, sir.
Okay.
Yes, sir.
Where is
Sir, just a minute.
Okay.
दिखा नहीं है?
Just a minute. Producer is showing something. It's open. Okay. And see, that was the Python script for the existing ready-made gripper, which can be modified. Also, like the program which you create, these themselves can also You can generate a program here. Can you see this, sir?
Yeah, I am able to see. Okay.
You right click on this, generate robo program. And here it is available for you. Here also you can go and edit it.
Okay. We have to do on a part.
Okay, fine.
Thank you. Can you share this recorded session to us, the link of the recorded session? Anything?
Yes, sir, sure, sir.
Please share in the group, so that we can later also.
Yes, sir,
Thank
we will share it in the community. Sir, the feedback form is, so please fill the feedback form from the community, sir.
In the community. Okay, right.
Yes.
Thank you.
Yes, sir. Thank you, sir. Thank you so much.
Thank you all of you attend this webinar. We are dropping the link of feedback form in community. Please kindly fill this feedback. And thank you.
ನಟರಾಜ್ ಮಾಡಿದೀನಿ ಸರ್ ನೀವು ಒಂದು ಮೆಸೇಜ್ ಹಾಕ್ರಿ.